Alright, today we are demonstrating GMR Flex. Nice thing about GMR Flex is the whole thing fits in the back of an SUV, so it's very portable, nice easy surface NMR system. So let's get going. This is an area we use for testing, training. It's a good area for doing just GMR measurements. Pretty rural, right near Everett, the city of Everett, the floodplain of this Snohomish River. More cattle. You see this electric fence over here. This is a big noise source for surface NMR. Yep, that's active. Electric fence, and we will see that in the data. Oh, this one's pretty dry out here. Alright, Greg and I are going to set up this GMR right here, right off the back SUV. Goes on that side. About here. And here's our tuning unit. Most of these components are single man, portable, which is nice. So I like to connect the battery at the very last thing, so always use the battery, connect the battery last. Right, this is the safety plug. That just covers the input to the additional off-board capacitors in the event that you're not using them. That protects the user from any sort of electrical hazards. So today we're going to be using the off-board capacitors. So we're just going to plug it in. GMR Flex, these are nice batteries, these little Duracell, a lot more easier on your back than big marine batteries. These are 35 amp hour, that'll be plenty for today. So GMRs run on 24 volts, so we get two 12 volt batteries. We just make a 24 volt by connecting two of them in series. Here we go. Alright, let's do the surface coils. Okay, we're going to start with, for our detection coil, we're going to use a 35 meter 2-turn circle out there. That's going to give us good impedance balance for the output of this device. And it'll give us good resolution on the top 100 feet here, which is where we're really interested. I'm going to do 2 turns, so we just add another cable in series. So we're going to have plenty of noise here. We'll have noise from the power lines, from the gas line, and from 2 different electric fences here. Just doing a single turn on this reference loop, and the exact shape and diameter don't matter. Okay, I'm plugging the reference coil for the noise coil into this other one that says reference coil, right? TXRX coil, that's for the detection coil. This is for the reference coil. Different size connectors, so you can't get them wrong. So all of the GMR cables use these environmentally rated high voltage connectors that are appropriate for the application. It's a fundamental safety feature of all GMR equipment. Never have to touch the electrical contactor with this equipment. Everything else set up now. Now it's time to plug in the battery. And with GMR Flex, you'll notice you get this green light here. Green LED comes on anytime the battery is plugged in. The rest of the system's not powered, but this is giving power just to the internal data acquisition. So that's right. Everything else is off. We've got everything set up here, everything's plugged in, and we're going to run a measurement. Okay, now I'm going to configure the sequence. First I'm going to set the tuning capacitance here. It's 7.5. Preamp gain is in high position. And I'm going to program my sequence. Now there's a bunch of different sequences you can select from with the GMR. They all do different things. We're going to just do the simplest one right now. This is the free induction decay signal. So that's the NMR frequency here. I'm going to select 25 millisecond pulse length, 4 seconds on the TR, and the rest of this looks good. Now we're done, and now I'm just going to say run acquisition. Software is going to ask you to make sure everybody's away from the surface cables. All the parameters are correct. The DC voltmeter's at 0, yes, and now we can turn on the power. So that's the main power to the system. Now we're energized, and we click OK, and we're going to start acquiring data. As we're just starting the initialization procedure, this first thing the software does, it basically steps up through different pulse levels, voltage and current levels on the coil, to sort of automatically figure out what's the maximum bus voltage you can use, and it will set to get your maximum depth of investigation for this particular sequence. So that's what it's doing now. This takes 2 or 3 minutes typically, and we started this at 4:24 p.m. Here you can see on the left you got your current pulse, 200 amps currently, and your voltage on the coil plus and minus 1700. So it's still in the initialization stage here. It's still stepping up, trying to get as close as it can to those two limits. Alright, the initialization just completed, and now let's see, that took 3 minutes. It's 4:27, and now we're starting to acquire data. You can see the bus voltage charging up here on these capacitors, and as soon as it starts transmitting, you'll see the bus voltage droop. Why don't you come a little closer and you can hear the chirping. Okay, so we've got 2 complete stacks of data already. It's now 4:32 p.m., so we've been going for about 5 minutes. But we have enough data already to detect and maybe even invert a signal. So I'm going to the GMR QC program. That's the first. And what we do there is we do noise cancellation and stacking of data. So there's the NMR spectrum. See these really bright lines in the spectrum? Those are from that electric fence that's behind us. So we're going to just eliminate those records completely. Just go in and aim the mouse at them and click on them, and that gets rid of them. And by getting rid of the electric fence noise, we'll do a better job of canceling the other noise. See how much better noise cancellation suddenly got once we eliminated most of those electric fence impulse noises. Now there's your NMR signal. You can see the spectrum of it right there in the middle. I think I'm going to get rid of this one too. Right. And in the time domain, there's your NMR signal. Nice. That's just from the first stack. Alright, so yeah, we ended up just doing the QC on the first 4 stacks, and this is basically what you got. There's a nice NMR signal, very nice NMR signal there on the left. Short NMR signal. And as a function of pulse moment, you get you're getting signal across a wide range of depths. So not unusual at this location. So let's go and do a quick inversion with this data. Even though we only got 4 stacks in the background, we're still continuing our acquisition. We're going up to stack number 7 already, and it's about 4:41. We've only been going for about 20 minutes, maybe less. So we'll just start with the resistive earth. Even though it's kind of conductive here, the ground, let's just do a resistive earth inversion. So we'd be able to, looks like we're going to be able to image to about 33 meters. This is going to be our resolution limit with this sparse data set. And now we're seeing the NMR signal as a function of depth. This is the output of the inversion. Now we're 3 meters. We're starting to get into an aquifer there with a bit of a longer signal. And looks like deeper there's a bigger aquifer here. It looks like more like about 15-20 meters down is where you've got a much more porous, thicker aquifer. It's interesting. We've got 2 aquifers here, or 2 permeable zones. So here's our inversion. We got this first one. We had some longer signals in there you saw as we were stepping through, and then there's this thicker aquifer below, which has shorter signals but high porosity. Very interesting. Well, we're going to continue to collect more data, probably get at least 8 stacks here. We can invert that. Alright, so we finished 8 stacks on that first sequence. Now we're going to do a different pulse sequence. We're going to go back with the acquisition, go back to this menu, and we're going to configure for an adiabatic pulse. Adiabatic's pretty cool because it gives you a bigger signal. So let's see, we're going to do 60 millisecond pulse length. And we're going to do a 300 hertz sweep. Well, as you can see, weather's starting to deteriorate here. So got some rain coming in. So we're just going to probably wrap this up. We're going to do maybe 1 stack already on the adiabatic pulse sequence. It's 4:53 p.m. So we'll probably get 4 stacks, maybe 6 on this pulse sequence, then we'll pick it up and get out of here. And so one of the nice things about the adiabatic sequence and the GMR Flex in general is you can collect really good data really fast. You don't have to sit around for 3-4 hours like in the old days of the old equipment from the old manufacturers. Alright, so it is 4:57 p.m. We're still acquiring data with these adiabatic pulse sequence, and we're just starting stack 4. So I'm going to start QC the first 3 stacks that we already have. Again, we've got this electric fence right behind us, about less than 100 meters away from our main detection loop. The wind is picking up, the rain is getting closer. The tension is palpable. So I see that nice big signal there. You always get a bigger, almost always get a much bigger signal with an adiabatic pulse than you do with the free induction decay.
Yeah.
Alright, so it's getting, we're gonna have to leave. So weather's coming in. Right now it's 5:04 p.m. and we are on stack number 6 of this adiabatic sequence. And I'm just gonna stop it at the end of 6. And then we're gonna pick up and leave. Let's see how quickly we can get out of here. Greg's raring to go there. He's got his cable reel. As soon as we power things down, then we can start unplugging things. You don't unplug anything until your power's completely gone from the system. We picked, I think this is the first time it's rained here in like 6 weeks, and this is the day we picked to do our video. But that's it. This is the GMR Flex. Let's get out of here. Just in time, 5:20. So how much time did we spend? When did we start the collection? I think it was 4:20 or something like that. Less than an hour later, we're already out.